Hello dear student, myself Pranali Kakar. I again welcome you all in our video lecture series for the database management system, that is DBMS. From last video or in some previous video, we are completing the topic Introduction to the Database Management System and Entity Relationship Model. From this video, we are moving toward the new topic, that is relational model. We discussed that there are entity relationship model, relational model, hierarchical model, network model. There are some example of data model, right? So relational model is one of the important data model in a database management system. So how the structure of relational data model? It is a collection of table. Relational database is a collection of table and each table assign a unique name. Okay. So table is a collection of relationship. You already studied a relation concept in a district mathematics. So what is relation? We know that relation is a Cartesian product of subset or domains, right? Similar way, your table in a relational database consider as a similar to the mathematical concept of relation. How? Because in a table, it is a Cartesian product of attribute or Cartesian product of columns. Therefore, in a relational database, table is similar to the mathematical concept of relation. Okay. So in a row in a table is represented a relationship among the set of values called tuples. Okay. So the record in the table is termed as tuple in a relational database. Dear student, the relation models store the data in the form of table. We already discussed. So this concept is introduced by E.F. Codd. He is a researcher of IBM. The relation model is the first choice of commercial data processing application for storing the data, manipulating the data, or the performing operation on the data. So relational model is most famous because we all know that it is a tabular format structure. It is a simplest structure compared to the network hierarchical model. So relational model consists of three major components as shown here. It is a data structure, data integrity, and data manipulation. So relational model consists of set of domains and set of relation. It's termed as data structure. Data integrity is a integrity rule for your relational data model, and the data manipulation, that is operation on the data using SQL, that is a different programming language. We perform operations on a relation, right? So this is the introduction for your relational data model. In our this is example, let's see the example for the relation uh, data model. See here, this is the attribute account number, branch name, and balance. So table is known as relation in a relational data model. Why? Because it is a Cartesian product of all attributes in that table. Dear students, this is one attribute, second attribute, third attribute, right? So these are the columns mean attribute of your relation. Now, and this relation, this is one tuple or one record. So this is termed as tuple or record. So how many tuples in this relation? There are 1, 2, 3, 4, 5, 6, 7. 7 tuple and 3 attribute or the column for this relation, right? In this way, this is a very simple form of data model in which the data is stored in a column and row format, that is tuple and column format. Now, in DBMS, we say column. In RDBMS, we refer it as an attribute. See here, in the last example, we already discussed these are the attribute, right? In this way, it is a in DBMS we denote as a column type. In RDBMS, we refer as a domain. What is mean by domain? See here. Let's take an example for a balance attribute. In a balance attribute, we store which type of data? Yes, it is numeric type of data. Therefore, the data type for this attribute is an integer or numeric value. So, in RDBMS, this is termed as domain, that is column type. Okay. Now, row. In DBMS, we refer it as row, and in RDBMS, we term row as a column, tuple. Okay. Now, it is a column value is termed as attribute value. See here. For tuple 1, branch name column value is downtown. This is termed as attribute value in a RDBMS. So dear student, this is the basic 3 component of your relational data model. It is a set of domains and set of relations. We perform operation on a relation using different programming language such as SQL, that is data manipulation, it comes under this point, and integrity rule. There are some integrity constraint are applied in RDBMS, which is a very useful concept in case of database management system. Okay, or preferably in a relational database management system. So see here, in a relational database data model, relation is termed as table. Table means relations. Okay. Tuple means rows. Column, name of the column is an attribute. See here, the basic structure of your relational data model. These are the attribute A1, A2, A3 up to AN. So these are the attribute value, and this specific set of attribute for a single record, that is row of a table, is termed as a tuple in a relation. Okay. Now, domain. What is understood by domain? It is a set of value assigned to the attributes. Set of value assigned to these attributes is termed as domain, such as data types like integer, character, varchar, Boolean, all this. Relation. A subset of Cartesian product of one or more domain is termed as relation. Yes, our one relation is get formed with a Cartesian product of these attributes. Right? So, it is a relation is a Cartesian product of one or more domains. Then set allowed tuple is a row of relation. This is a rows of relation is termed as set allowed tuples. Now cardinality. So number of tuple for each domain are. This is the number of tuple in this A1 domain is termed as cardinality of this domain R. Right? So in this way, this is the basic concept for relational data model. Now we are moving to the advantages of relational data model. The first point is ease of use. So the system which is managed in the form of table consisting of rows and column is much easier to understand, right? Next is flexibility. The information from the multiple table can be revised easily at a time by joining the table. So it is more flexible than entity relationship model, network model, or any other model. So the your relation model is more flexible to joining one or more tables or one or more relation. Next is security. In a relational data model, we all know that we uses different type of integrity constraint. Using this integrity constraint, we set a levels to access the data based on their rules. We already discussed the level of abstraction, physical level, logical level, view level. So using this data abstraction, we achieve the security in the relational model. Now data independence. So dear student, in a relational system, we can completely separate the data structure of the database and the programs for the application. This is termed as data independence. Means what? Suppose you can modify the size or data type of the any data field, that is attribute of the table, without making changes in an application program. So this is termed as data independence, and it is possible in a relational model. So this is one of the most advantages of your relational model. Next is a data manipulation language. In a relational database approach, it is easy to respond the query by means of language like structural query language, relational calculus, relational algebra. We will discuss in a unit number 2 for this topic. But you can remember here only the retrieving of the data, managing of the data, performing the various type of operation on the data. It is a very easy in a relational data model. So dear student, we already covered that this relational model is introduced by one of the IBM researcher named as EF Codd. So Codd designed some rule to define what is required for the relational database management. And dear student, in a database management system, these Codd's 12 rules are very famous. So we will study all these Codd 12 rules for the relational database model in detail. Let's start. So dear student, a relational database management system, that is RDBMS, is a database management system that is based on the relational model. We already discussed what is relational, and that is the consist of multiple tables, and the relationship among this table are formed or introduced by EF Codd, one of the researcher at IBM. So a short definition of RDBMS may be a DBMS in which data is stored in the form of tables and the relationship among the data is stored in the form of table, right? So EF Codd is famous mathematician, has introduced a 12 rule, that is 0 to 12, that is 13. Actually there are 13 rules, but the numbering for this rule are from 0 to 12. Therefore in the relational database concept, this Codd's 12 rule are a very famous, and which give the actual standardization to your relational database model, right? So dear student, we will see rule number 0. We start from rule number 0. This is a very basic rule, or it is also known as foundation rule for your Codd's 12 rule. So let's see. First we read out. Any system claims to be RDBMS must be able to manage database entirely through its relational capability. Yes, dear student, if we say that this database is belonging to the RDBMS, then it is based on entirely through the relational capability. What is relational capability? Yes, it's Codd's 12 rule. So all these rules are must get followed by the data model. Then we say that our data model is in the RDBMS. Okay. So all the data definition, manipulation must be able to do or done able to be done through the relational operation. Yes, what is relational operation? Yes, it is a related to the relation, that is table, row that is tuple, column that is attribute, in the form of tabular format or the relation format. So this is a very basic foundation rule. Actually rules is get it started from rule 1, but rule 0 said that all the 12 rule, if followed by any database system, then we say that that database system is modeled as per the relational model. Okay, so first rule is information rule. So dear student, first rule says how your information is get stored in a relational model. We all know that our information is get stored in the format of tables. So this rule says that all information in the database is to be represented one and only one way, and that way is in a tabular format. Yes, this is achieved by the value in a column and row of the table. So this is termed as information rule, rule number 1. So the basic requirement of the relational model is table, table name, column, column name and column data type should be available in the same table within the database. So this is the basic requirement, and this rule says that all the information in the relational database are get stored in the form of tables. Now see here the basic structure of the information rule. Yes, our information or data gets stored in the tabular format having these attributes, different attributes and different tuples. These are the tuples. So tuples and attribute form a one relation. So our information gets stored in a relational format. Now rule number 2, guaranteed access rule. So dear student, this guaranteed access rule is say that how we access the data from the relational model. See here, each unique piece of data should be accessible by table name, primary key and attribute. To access the data, we use table name, primary key and the attribute name. Okay, so using table name, sometime using table name plus primary key, sometime table name plus attribute, or sometime table name plus primary key plus attribute. So using combination of these three terms, we can access a data from the relation. So all data are uniquely identified and accessible via the entity. So most of the RDBMS, that is relational database management system, do not make the definition of the primary key mandatory and are deficient to the extent. So some case in some relation there is a no primary key. No problem. You can access the data from table name or attribute name. Yes. Okay. So this is the structure again. See here. If I want the name, first name for the student ID this. So yes, I can access. For this I uses table name, this attribute name and this primary key. So in this way we can access any data. So this rule is termed as guaranteed access rule. So dear student, we can access the data in a relational data model using the table name, primary key and attribute or column name. Yes. Now we are moving to the third rule, that is systematic treatment of null values. Yes, your third rule is related to the null value. This null value must be given in a systematic and uniform treatment. So why this null value is needed? Yes, dear student, this null value is used for the representing missing information. Your null value is used for representing the missing information. So null value, that is distinct from the empty character string or a string of blank character, we uses a letter null, N-U-L-L. So this null value are supported in a fully relational DBMS for representing a missing information and inapplicable information in a systematic way. Okay, and there is a no data type. there is a no data type for the null value. So from this rule number 3, we are understood the concept of null value. Null value is used for representing the missing information and inapplicable information, and this null value are independent of the data type. Okay, so this is a systematic treatment of null value in a relational data model. So nulls maybe mean missing data and not applicable data. Should be handled consistently, not zero or blank. So null is different than not zero and blank. Okay. And there is a one constraint for primary key and null value. So your primary key never ever having not null value. Okay. So primary key is not null in a relational database management system. So expression on a null should give null. Okay. So expression means we use a select query. So select null. If I pass a expression on a null value, so it returns the null output. So separate handling of missing and or non-applicable data we uses null. This is a distinct to zero and empty string. Again I repeat, this is a distinct from zero and empty string. So this is rule number 3. So see here, in this database, this is null value. Okay, you can place directly null also, or if there is any blank spaces, it is a denoted by null in a relational database. So it is used for the data missing or data is not applicable. Okay, so next rule is database description rule. So dear student, this database description rule says that it is represented at a logical level in the same way as a ordinary data, so that authorized user can apply the same relational language so its interrogation as they apply on the regular data. Dear student, rule number 4, database description rule says that our description of the structure of entire data is known as online catalog or known as data dictionary, right? So this data dictionary can be accessed by the authorized user, and this metadata should be maintained for the data in the database. This is termed as metadata, that is a information about the authorized user. Okay, so this authorized user can access the database structure by using common language, that is SQL. Okay, so the information about the authorized user is placed in a metadata or data dictionary. So this authorized user access all this data or all these relation in a simple interrogation manner. Okay, so as he or she access the normal data, similar way he can access the authorized user can access all the data using SQL language. So this is known as database description rule. Now fifth rule is related to the comprehensive data sublanguage. So dear students, this rule number 5 by CODD says that database should not directly accessible. It should be accessible by using some stronger query language. Yes, at least one strong query language. So this query language having the property has a linear syntax, can be used both interactively and within application program, and this language supports the data definition language, data manipulation language, all the transaction management related queries, security related queries, integrity related queries. All these concepts are get satisfied with this programming language. So database cannot access directly with any programming language, but it may be accessed with the help of those programming language who satisfy all these conditions, that is data definition, data view definition, data manipulation, integrity constraint, authorization, transaction boundaries. So this type of all concept get satisfied by that particular programming language. So RDBMS should provide a language to allow a user to query to access the data from the database. Right. Now next is a view updating rule. So view means virtual table. We already know that view means virtual table that is temporarily derived from the base table. So suppose I have a suppose I have multiple column with me, and there are suppose hundreds row with me, but I want to interested only in this two row and this three column, right? So that time I make one virtual table which store only this three column with these two tuples. Okay, these are the attribute, right? So these three attribute and these two tuple are get transfer into a virtual table. So the sixth rule says that view updating rule. Now your RDBMS must support the virtual table. So if a view is formed as a join as a three table, changes to view should be reflected in a base table. So dear student, view can be created from single table or view can be created from the multiple table. So this rule suggests that it allows the update of simple theoretically updatable view, but disallow attempt to update the complex view. Okay, for the security purpose, there is some authorization also needed for the complex view. So this rule number 6 is for the view updating rule. See here, below a table named student, RDBMS gives us facility to view only some particular field according to your need, which is directly accessed from the base table and when it is required. So it enhances the security for the database management system. So use of view is a very good idea in a RDBMS. So see, in this way, to view only the name and marks. So this is the original table having name, class, marks, and pin number, right? So in this way, suppose I am want to give only name and marks to some user, I want to give access only for the name and marks, then I create one view using this syntax, create view, and from the record, from where you can create a view record, this view name as a record, and in this view select name and marks from the student table. So view is created, and this from this student table, from this original student table, only these two attribute are get placed into a virtual table. So this enhance the security for the RDBMS. Now rule number 7 is related for the high level insert, update and delete queries. Yes, this rule state that insert, update and delete operation should be supported for any retrievable set rather than just for a single row in a single table. Yes, you can delete multiple row, you can insert a multiple row, or you can update a multiple row, right? Or you can retrieve the data which is accessible for you. So it is also perform the operation on multiple row simultaneously. So this is related to the rule number 7. Suppose if you need to change ID, then it will reflect everywhere automatically. So this is say see here, SQL create a table student data having the name is the one attribute, varchar is the data type. So how to create a view, how to insert a row, we will study in unit number 2. But just for the sake of understanding this rule for the relational database, in this way, using this syntax, we create a table. We definitely see the syntax and each and every term, how to create a table, how to insert information in that table in the unit number 2 using SQL language. But see here, at a time we can insert multiple rows in the same table, right? So this is the rule number 7, high level insert, update and delete operation. Okay, now next is a very important rule, that is logical data independence. Dear student, see here what this rule says. So what is independence? Dear student, this rule says that suppose there is a one database, consider. So dear student, see here, independence means suppose I want to modify the schema definition on a particular level. At that, if I modify the schema at one level, it does not get affect the schema's definition in the next higher level. So this is termed as data independence, means the ability to change the logical, that is conceptual schema without changing the external schema. So what is conceptual schema, what is external schema, we already discussed in a unit number 1 in a previous video. Okay, so if I make any changes in a conceptual schema, there is a no effect or without affecting on a external schema or a view schema. How? See carefully. Suppose I have one database. In my database there are 10 to 15 columns or 10 attributes, but I want to change the domain. Domain means what? Data type for a particular attribute. Suppose there is a name attribute in my table and I want to change the domain size or the domain for that name attribute. If I update or alter this domain for the name attribute, then it does not affect any external schema, means at a user level there is a no there is a no change is required. So this is termed as independence. All of you get understood? Okay, so this is a very important rule, that is logical data independence. Suppose the addition or removal of a new entity's attribute or the relationship in a conceptual schema should be possible without having to change existing external schema or having to rewrite existing application program. Dear student, again I repeat, if I do any change for the conceptual schema, it does not affect on a application program also and for the um, view level also or for the external schemas also. Okay, so this is termed as logical independence. Similar way, physical data independence. In the physical data independence, if I do changes in any physical device such as storage device, optimization, indexing structure, so there is a no effect on the external view or the view level. This is termed as physical data independence, rule number 9. Now rule number 10 is related to the integrity independence rule. So data integrity refers to maintaining assuring the accuracy and consistency of the data over the entire life cycle. Yes, data integrity is a very important. First, ensure that correct data type is used. Means what? Suppose I declare a date type of data type for one column and I want to insert a numerical value. So or if I declare the date type format as YYY MMM, okay, and DDD. So this is the domain type format for the date. Okay, if I want to insert the value in this way 1 2 5 6 7 or A B C, so this violate the integrity rule for the domain. Okay, so first ensure correct data type is used. Check the constraint. This allows a column value to be checked agency other. So this is termed as. So dear student, the rule number 10 is refers to as integrity independence. So integrity constraint must be specified independently from the other application program and stored in a catalog. We should able to make changes in an integrity constraint independently without the need of any change in an application. Yes, integrity constraint is set at the uh, structure definition stage, right? Suppose I ensure in the integrity we check the data type for the attribute, right? We check all the primary key constraint, foreign key constraint, all this type of integrity is set at a structural level. Okay, so these all integrity are specified in the online catalog or the data definition. Okay, so this type of integrity independence, if I change the integrity at the middle stage, okay, at any stage, so this changing integrity does not affect the external or view level. Okay, so this is termed as integrity independence rule. Next is a distribution independence rule. So this is the basic aim of DBMS. What? So distribution of database at a various location should not visible to the end user. Yes, we all know that for the user, where the data gets stored is hidden to hide the complexity of the data structure. So distribution independence rule says that user should not aware whether database is distributed at a different site or not. Yes, our database is situated at a different site, but user is feel like data is get stored at a one place only. So this is termed as distribution independence rule. Okay, so RDBMS may separate across the one or more system or one or more network, but user from the user this RDBMS hide the complexity. Okay, they feel the user like data is placed at a one place only, but actually he uh, do not aware that where the data is placed. So this is termed as distribution independence rule, and this is the main purpose of your using database, that is it hide the complexity of data structure from the user. Now next rule is rule number 12, that is non subversion rule. Yes, there should be no way to modify to database structure other than through the multiple row of the database language, that is SQL. Means what? Suppose I give a access to 10 table to one user. Okay, but there is this is the one boundary. Means what? After that user can access only this 10 table. So this non subversion rule says that there is a no hidden way to break this security. Okay, so for that user he can access only uh, those table which is provided by the integrity constraint. So to break the integrity constraint, to break the security, there should be no bypass way, which is said by this rule number 20, that is non subversion rule. Okay, so dear student, dear student, this is all about COD's 12 rule for the relational database management system. Yes, this is a very theoretical concept. You just remember a basic keyword from that. That is, first information rule says that where the information gets stored, how the information gets stored in a tabular format. Guaranteed access rule says that how you can access the data from the database. Systematic treatment of null values is associated for null value rule. Okay, database description rule says that authorized user and non-authorized user. Comprehensive data language says for interrogal data, or the you can access a database using particular programming language. View is related for view updating rule is related for view level. So high level insert, update and delete involves the you can add, insert, delete and update multiple rows simultaneously. So in this way, these are the 12 basic rule introduced by the code to understanding or better gives the standard to the relational data model. So dear student, for today we stop here. Thank you for your patience listening.